up, everyone? What's up, everyone? Hope the quiz went well. Just give me 1 sec. Actually, I don't even want to finish that. All right, let's just do this. Skipped a line on the quiz. Oh, shit. I don't know if that's unlucky, but yeah, that still sucks. Skill issue. Yeah, how'd everything go on the quiz? Hopefully it went well. Quizzes, plural. And we'll try to we should be able to get the quizzes turned around pretty quickly. Gerline, if you're in chat, like I said, I don't have anything to say that I could really say publicly, but we'll talk about grading. But there's none stopping you if you want to get started right now. Yeah, I don't really have anything to say about the quiz. I think I said it all in my 2 emails. And the Piazza questions are starting to come in. Actually, I only got one about the quiz right now, so hopefully things went well. Can we submit images to Autolab? You can submit any file at all. Why would you ask that? I sent 2 emails about this. Yeah, you can submit images. Does it matter if somebody misses an arrow on a stack frame? If it's a return arrow? I mean, it does and it doesn't. So the bar for passing the quiz isn't ridiculously high. Like, we don't demand perfection on passing the quiz. You can make some mistakes as long as those mistakes aren't fundamental to the learning objectives that we're assessing. So for these quizzes, the learning objectives are: can you trace through the execution of programs that use classes? We haven't done inheritance and polymorphism yet. Those are 2 different quizzes, classes 2 and classes 3. But we just did classes 1. Well, tracking the state of stack and heap memory using memory diagrams. Nowhere in there does it really say, do you have your return arrows in the right place? So missing a return arrow, not fundamental to classes. Classes, I'm looking for the constructor calls being on the stack. I'm looking for the objects being on the heap. I'm looking for passing references. There were 2 instances where a reference is assigned to another variable. One where it's just account 3 equals account 1, and then the other one which is a method call. Those are the big things that we're looking for. So anything that's just incidentally wrong, that's kind of not really related to the concept of classes, which includes objects and references, I'm not overly concerned about. And you can still pass missing some of those things. Second chases are on the last day. Yep. Clutch with 2 minutes on the clock after rewriting it. Nice. I went a little out of order here. Making sure I didn't miss anything. Image. Yeah, the image doesn't show up. Oh, yeah, this is the Piazza question as well. That was explained in my email. I felt like I explained it pretty well. I mean, maybe not. Right? That was in my email, right? Now you got me second guessing myself. No, you may submit any valid image format Autolab is expecting PDFs. If you submit something that's not a PDF, you won't be able to view it in Autolab. Like, I can't be much more clear about that. You just got to read my email that I sent. Kind of choke on linked lists, but you think you did good on the first one? Yeah, it's all right. And the way the grading works is your for the quizzes, you can get 4 application objectives out of the 6 quizzes. So if you get 4 out of the 6 in your first attempt, then you're maxing out your application objectives for the quizzes. Those numbers are carefully chosen, so even if you completely choked today, it still doesn't affect your grade as long as you crush it the whole rest of the semester. You can still max out all your points. And even with total AOs, you can still miss 2 of them and still get an A. So there is some flexibility even in the application objective side of things. And of course, in the learning objective side, you get lots of attempts. So nobody, after today, nobody is out of the running for an A. Since there's also 2 programming assignments of Slack, you can still max out your expected deadlines. Since there's 8 programming tasks and you max out at 6. So the 2 expected deadlines that already passed, like nobody's out of the running for an A, and in fact nobody's even out of the running for 10 application objectives. So everybody, even if you did nothing at all so far this semester, you still have 2 application objectives of wiggle room to still earn an A. So even if you had a rough start in the semester, personally I think if you had a rough start in a, like we're going to be 2.5 weeks into a 6-week course, so in my opinion, if you're having a rough start, you're probably just gonna unfortunately fail. But if you know your shit and you're keeping on top of everything, but for whatever reason you just struggled, maybe you had a life event or something that occurred, you can still earn that A at this point in the semester. All right, no more questions. Quiz is behind us. Will you show the quiz solution after grading? I'm not opposed to it, but I don't plan to. I don't intend to. Show the quiz solution. If you want to talk about it in office hours, I'd be happy to go over it and stuff, but I don't intend to go over the quiz solution or release it electronically. I mean, honestly, the quiz was very similar to things we did last week during lecture, so that would be like a solution to a different quiz would be what we did in lecture. Last Tuesday would be like I played it pretty close to lecture slides. The examples we did here, pretty close. The very first one especially was pretty close to the solution today. That one's not the memory diagram. Ugh, come on. Like this is very clearly modeled, the quiz is modeled after this. I even got, the same setup, creating 2 objects and then doing another one that's assigned by reference, and then modifying one of them objects and then getting the other one, making sure that you understand that changes to P1 reflect changes in P3. This is the same thing as the quiz. So I would use this as your solution. This should have been your study guide and everything. If you studied this memory diagram, there shouldn't have been any surprises on the quiz. And same with linked lists. When we did the 2-string call, the quiz was really modeled after this. We threw 3 nodes in a linked list, called a method that's going to use recursion, and then get whatever's returned by that recursion, getting the stack frames and everything. I had a little bit extra here because I prepended and appended, but it was really modeled after this. So these are the things you should have studied to prepare, and can be used as effectively solutions. No, it won't be the exact same quiz. Are you crazy? It'll be different code with the same concepts. All right. Yeah, I can't do the exact same thing. I might as well just make it an open book quiz if I'm doing that. Or sorry, not open book. It was open book. A take home. All right, so let's get on with some lecture. Today is pretty open-ended. How much leeway do we have to pass? That's a question I always get, understandably. You should have that question. But one that I don't have an exact answer for, I'll stick with the answer I've been saying, is that as long as you didn't show any fundamental misunderstanding of the learning objective of the course, then you'll pass the quiz. So any mistakes that are not related, they're kind of incidental mistakes that aren't related to the learning objective of, do you understand how classes work, how objects work, how objects go on the heap and references go on the stack, and how references move around your code as they're assigned to different variables. If you have any misunderstandings in those aspects, it's going to be a fail if it's a fundamental misunderstanding. Like grading the quiz, here's kind of how we'll grade the quiz. We'll pull up your image, of course, step one of grading. If there are 3 objects on the heap, that's pretty much an auto fail. You don't understand how assigned by reference works. If what's printed to the screen doesn't reflect the change that was made to the other object, that's going to also be... let me pull up the quiz so I can get the specifics on here. I'm talking, of course, about classes 1 quiz. Let me pull it up. So when we transfer funds from account 2 to account 3, or it was the other way around, wasn't it? Well, let me make sure. Other account withdraw. So we transferred funds from account 3 to account 2 and then get the balance for account 1. I need to see that you understand account 1 also lost $50. If you didn't get that point, you don't understand pass by reference for the method call, and that's pretty well an auto fail as well. If you have the wrong number, like it was 100 minus 50, so if you have like 60, like whatever, as long as 60 is the value that's on the heap in the object that's referred to by both account 1 and account 3, like I'm all right with that. But if you put 100 as being printed to the screen, that's just flat out wrong. You don't understand references. So I need to test you again. I need to assess you again, and you need to study some more so I can make sure that you understand references. And here's the crux of it before you move on to 220, because in 220, if you don't understand how references work in Java, you're just going to be completely sunk when you get into 220 and you're trying to understand how both references and pointers work in C. You need to understand how references work in Java, which is a very much simplified version of references and pointers. Our references are effectively pointers in C, just to make sure things are confusing. Sudden dread of not remembering how objects you had on the heap. How many objects? Yeah, when I say 3, oh shit, did I have 2 or 3? Oh my goodness. No, there's got to be 2 though. The word new, the keyword new shows up twice. You got 2 objects. Withdrawing from account 2. And I had 2 different method calls. One where the reference this, I'm watching to make sure that you know the reference for account 2 is stored in the variable this. And then the second one, account 2 is in this, and account 3 is in a variable named other account. So making sure that you know how your references move around. Those are the big things that we're looking for. If your math is off, if you wrote 10 instead of 100 and then you got to negative 40, like little things like that. Your return arrows. If you don't have the names of your method calls next to your stack frames, like we'll put a note in the feedback, but it won't be a fail. You'll pass as long as you got all the classes, objects, and reference stuff. Making sure your constructor calls have this being a reference to the object that's being created. Making sure you have your references to begin with. Those are all things. If you miss one reference, well, I'd have to see it. That'd be a case-by-case situation. And then since I'm going through this, I might as well go through DS1 as well. Oh, I meant to change this. Bear with me 1 second. I gotta do one quick thing here. Alright, and then DS1 quiz. Oh, by the way, today's lecture, it's testing tips is what I'm calling it. I'm going to go through the tests that I gave you in the homework handout and then go through some debugging, our first debugging example. It's going to be a live demo, and there's no content that you're strictly held to today. It's all tips and tricks trying to help you understand, for one, what the homework is doing, what the autograder is doing for the homework, and two, being able to get you through the homework better. So it's all like homework tips and tricks. It's going to be open-ended, so feel free to ask questions. Anything that will help you through the homework, give me those questions so I can help you out. But we're not on like a time crunch. There's not like a amount of material that I have to get you through. So for the linked list, I'm pre-pending, then appending. So making sure that you understand how both of those work. Append is a recursive method, so making sure you can follow the recursion on that and follow how that's going. Size is another recursive method call, making sure that you see how that recursion goes through the linked list. And both recursions are in the linked list node class, so they're both passing the reference to the next node through the keyword this, so showing how that works, as opposed to the other way where you have a separate parameter for the node that you're visiting, and then just printing size to the screen. So 2 recursive calls and just showing how the linked list is assembled. And I made this, it's creating a node with just 7, pre-pending 5, and appending 9. So you should have 5, 7, 9 as your list in that order. So again, if we look at your heap space, and we follow the references, and it's not 5, 7, 9, it's pretty well an autofill. If you don't get the right order of the nodes, we know you don't really understand how nodes are linked together to form a list, which is pretty fundamental to linked lists, I'd have to say. You have to understand how nodes are linked together to form a linked list. And trace through programs that use linked lists. Of course, this is DS1, DS2, DS3. Using memory diagrams, so tracing through how a linked list works in memory is the big thing. If you mess up some of the recursion, recursion isn't explicitly a learning objective here. It's about linked lists, so recursion is kind of incidental. If you mess up the recursion a little bit, maybe your size, you miss a stack frame, I think that could probably be overlooked. But getting the wrong order of the nodes in the heap that's pretty fundamental to how linked lists work. All right. So with that, if there are more questions about the quiz, I'll happily testing right here. This is what I want. All right. So for the test, I want to explain a little bit about how the homework is set up. I always get questions about this, and something I can't explain too early in the semester because you're just getting your footing and trying to figure out what the hell's even going on in the course. But at this point, we're deep enough in that I can start explaining things and they'll start making more sense to you. So for tasks, I have 2 and 3 open, I should. For task 2, I have task 2 open, and task 3 we'll talk about as well. I gave you the testing for tasks 2 and 3. For task 1, which I think in the future I have to not do. I think I want you to test, as soon as to test these in the future. I don't know. I'll do something to change that. But I gave you the test for these. So the idea is that you write your code for task 2 and task 3, or obviously one at a time. You write your code for task 2, and then you go to your test classes 1, which is where the task 2 code is tested. Take all this code and comment it in. If you do control / you can comment it all in one go. I don't expect you to go line by line deleting the comment tags. Just do a big highlight and get all these tests commented in. Now, of course, there's going to be a lot of errors here because I don't have a song class. So you have to write your code first before these tests can run, because it's not going to compile. You have no song class. We can't create a new song. We can't call get song ID, get artist. I'm not going to do that because I don't want to just... Task 2 is probably the easiest task of the semester, if I'm being honest. It takes a little bit to just get a feel for how classes work to begin with. But once you know how classes work and understand methods, creating methods and stuff, it's mostly getters and setters, honestly. The only one where I got a little bit of challenge is rate song in the reviewer class. The rate song method is a tiny bit tricky, but not really. You're calling a constructor and then returning it. So this should be hopefully a little bit of it's too early to really be a break, but a little bit of ease into what's upcoming. So if you have a song class with a constructor that takes the 3 parameters that we expect, so a constructor that takes 3 parameters in this order, the title of a song, artist, and then song ID. In this order, this is one of the more common things that I see in office hours is you don't have these parameters in the right order, and then that just messes everything up. Not necessarily with task 2, but we are building, all 8 tasks are building up to a larger program. And in one of the later tasks, I don't know why or how, but students messed this up in a later task, even though they had it right in task 2. I don't know if they rewrite their song class, or I don't know, maybe they got a new song class from their friend or something. It's probably, it always triggers my AI warning signs when somebody has that in a later task, but they got through task 2. But anyway, make sure they're in the right order and then keep them in the right order. So I'm calling the constructor. You create a constructor that takes these 3 parameters in order, and then getters and setters for those 3 values. So I'm going to call your getter methods and make sure they return the right thing. So if I get the song ID, I expect to get this string. Whatever string I gave the constructor as the 3rd parameter, that's what I expect to get when I call get song ID. And they're strings, so I'm using the dot equals method. I'm not using equal equal for strings. And now is probably good a time as any. When I first introduce testing, I'm always going to use assert true, just your very first intro to testing. Assert true is super powerful. Give it any Boolean expression at all, and it'll just assert if it's true or not. There's also things like assert false if you want to not negate your Boolean expression and you expect it to be false, for example. But something that can be very useful now is assert equals. If I call assert equals and then give this 2 arguments, and then I have to import, oops, I got my key bindings different. Oops, I still hit it wrong. Make sure I import from JUnit. So now I got an extra import for my assert equals. Oh, and these imports would error. Oops, what am I doing? These will error, of course, as well, but they need to be commented in once you comment in all the tests. But assert equals, oh, I actually did import that wrong. I got the wrong one. Let me just do it this way. Actually, let me do it this way. I'll show you the be all end all of this. Just replace assert true with a star. That'll import everything from this class. It'll import all the methods from this class. So assert equals, get the song ID, give it what you expect. I always forget this. Yeah, I accept. Where does it even take me? It didn't even take me to the method. There we go. Expected then actual. I don't know why I always forget that. Your expected value should be the first one. So assert equals what I expect, and then what I actually have. And this will just make sure that those 2 things are equal. And this will actually call the equals method. So if you want to compare 2 strings, assert equals is sitting right there. You don't have to remember if it's equal equal or dot equals. If you call assert equals, it's going to call dot equals on those values. Can be a lot easier than using assert true everywhere. But if you want to use assert true everywhere and keep it a little simpler, that's fine too. So I'm going to call your 3 getters, make sure they return the right values to make sure that you have your parameters for your constructor in the right order. And make sure your getters are returning the right thing. Call your setters, and then call the getters again and make sure that they return what I expect after I set those values. So all that is tested. And notice that in this method, in your song class, you will have to have instance variables. They have to be there. If you didn't know that yet, here's spoilers, hints, or whatever. You need some instance variables to store these 3 values. That's implied, but never said explicitly here. I guess I'm saying it explicitly now. It's purposely not said explicitly here, so you have that connection when you're writing this method, or when you're writing the song class, that you should have that moment like, oh, this is why we need instance variables. I have a constructor that's taking parameters, and I need those values in other method calls in different stack frames. How do I communicate across stack frames? Well, let's store those values in the heap with this object, and then that object can remember the song ID, artist, and title without having to pull off some magic some other way. We store those in instance variables. Those instance variables outlive the stack frame, and then we can get those values in our getter methods. So that's the big thing that the song class is doing for us right now, understanding that, hey, I probably need an instance variable. The instance variable is going to solve the exact problem that I have right here. So that's kind of what you're supposed to be learning from writing the song class. The ratings class, pretty much the same idea. Reviewer rating. Let's do this in order. I guess my tests aren't quite in order. Pretty much the same thing to start. I'm going to create a rating. I'm going to call the getters. I'm going to set a value, get the value, make sure it changed. Then I'm going to continuously call the setters and the getters to make sure that I get the right value that I expect. And the big thing here is that ratings must be in the range of 1 through 5. So if I set the rating to 1, I expect it to be 1, 2, should be 2, 3, etc. But once the rating is outside of a valid range, the value should be set to -1. So if I set the rating to 6, I'm expecting -1. 0, I'm expecting -1. Anything that's not 1 through 5 is going to give me -1. And then that should also apply in the constructor. So I have a few constructor calls with invalid ratings to make sure that those are set to -1. This is where I recommended that you call your set rating method in your constructor, just so you don't have to copy and paste that code that's going to check for the range 1 to 5. You don't want that code popping up twice in your class. In the constructor, call the setter method, and then you can have that applying. Not universally recommended, even though in my slides I did recommend it. At one time I was recommending that, but it's just a little more awkward to do that all the time. If the setter is just strictly setting the value, there's no point. But if the setter is doing a little extra work for you, like it is here, it's good to call that setter in the constructor so you don't have to rewrite that code. The big danger of cut and pasting code, and we'll touch on this throughout the semester. One of the big dangers of cut and pasting code is, what if you change your rating system to allow a rating of 6? And in your setter, you go and update that, and you say, okay, 6s are allowed now, but you forget to change the code in the constructor. You have 2 different places where you have to update that code, and it's easy to forget one of those 2 places when you're updating the code for a new feature. If you have that code just one place, one time, and then you call the method every time you need to use it, now to maintain your code, to update your code, you only change it one time, once, forever, and then it changes throughout your entire code. That change can cascade everywhere where it's being used. Then finally, we have the reviewer class. So I'm going to call your constructor. You have a constructor that takes one parameter, which is the ID of a user. And then when I get the reviewer ID, I expect to get the whatever I gave the constructor, including capitalization. I got a lowercase j and a capital P, so I expect those to be exact. And then when we set the reviewer ID, I'm going to fix that capitalization. I expect get reviewer ID to have the new value that was set from the setter, not the value that was given to the constructor. So just making sure, again, that your getters and setters work. And then rate song. The hardest part of this homework, but not objectively hard, is that your rate song method will return a new rating object. So you do have to create a new rating object. This trips up some students, where rate song takes one. Let me back up a little bit. The rating constructor takes 2 values. One of those values you're getting from the parameter. When I call this with an argument, you get that as a parameter, and you're using that as the rating. But then to get the reviewer ID, you have to get it from the calling object. So Paul here is a reference to this reviewer, and then that reference is going to be passed to the variable this, and this is going to have that reference, and then you access that reference to get the reviewer ID. So that can be a bit confusing. That's why this is the hardest part of the homework, even though it's not mind-blowing, it's not objectively difficult. But it does test to make sure you understand how your references are moving around the code with that keyword this, which hopefully after the quiz today, that is much more clear after getting that practice with the quiz, how those references are moving around your code. But if you struggled on the classes one quiz, how to move those references around, you're probably also struggling on this method, I would guess. Until you understand references, it would be hard to do either of those. And then making sure our getters and setters are good. But rate song. Oh yeah, not the getters and setters, but rating song and making sure what rate song returned is correct. These getters were already tested in the previous test, so they should work, or in the one below it. And then rate song with an invalid rating to make sure that you have that check here as well, which this check should be performed by calling the constructor with 10. The constructor will call the setter with 10, and then the setter will say, whoa, that's an invalid rating. I'm going to actually set it to -1. So again, you're not duplicating that code. You're just letting your method that you already wrote do the work for you. So this is how we're testing classes, which once you get to task 4, you will have to write your code to test your own classes. The big takeaway with that when you start writing your code to test your classes is the first thing you do in almost every case when you're testing a class is to create an instance of that class. So you should call your constructor, get an instance of the class, because all of your non-static methods must be called through an object of that type. If I want to test a non-static method of the reviewer class, I need a reviewer object or a reference to a reviewer object. Go to the object on the heap for that reference and then call that non-static method through an object of that type. I can't do reviewer.getReviewerID because it doesn't really make sense. GetReviewerID is returning the specific reviewer ID for a reviewer object. So to go to the reviewer class and ask for a specific reviewer ID for a specific object, the reviewer class is going to be like, yo, I got like 17 reviewer objects out there in memory. Which reviewer ID do you want? You have to go to one of those specific objects and get the reviewer ID for that object. Do you want the ID of Jesse or the ID of Paul? Depends on which object you're asking for the reviewer ID of. Right. Let's keep this moving. I'll watch for questions if there are questions. But when you get to task 3, we have the testing for task 3 as well. We would comment in the imports, comment in all of this. Just in case I didn't mention it explicitly, this is all commented out because there would be compiler errors. Then when you're working on like your problem set, you wouldn't be able to run it because we have errors in the project. It can't compile. Everything in the project has to be able to compile to run any part of your project. So that's why it's commented out, so you don't get all the errors until you're ready for that task, for testing that task. So for task 3, you're asked to modify the song class by adding a little bit of functionality. We're going to add a linked list to the song class. You should have a linked list. I think I call this one out pretty explicitly, that you should have a linked list as an instance variable. This is, of course, really testing how well you understand linked lists and can you work with linked lists in your code. Can you write code that applies the concept of a linked list? Because just understanding what a linked list is, that's cool and all, but companies are going to pay you to be able to write code. If you can't write code that uses a concept, it's not super helpful. So let's take what we know about linked lists and turn it into some code that uses a linked list through the song class. So we're going to have a linked list of ratings. And we have quite a bit to do to test this. This one, I think it's too early in the semester for me to say you have to write your own testing. I think classes 1, I could get away with it. This one's a bit more involved. But let's talk about it. So for this, I'm going to create a new linked list. This should look very familiar to your quiz. I'm prepending both times here, so I'm creating a linked list of ratings. I'm creating a rating that I give for 3, then prepending Paul's rating and prepending Carl's rating. So this linked list expected is going to be Carl with 5, Paul with 4, and then Jesse with 3. In that order, Carl, Paul, Jesse. and the linked list of ratings has to maintain the order in which ratings are added. So we want to make sure that we're careful with how we handle the order of these ratings. I have to be aware that it's Carl, Paul, Jesse in this case. Creating a song, getting the ratings should return null because no ratings have been added. So making sure that when you call get ratings from an empty I'm just going to go through the code because I lost track of where I am in this. But making sure that if it's an empty list, this is going to return null. It's actually right here. If no ratings have been added, this method should return null. So checking that right away before I add any ratings. And I'm going to have a few helper methods in this code. Each one of these tests, it's going to have to perform a few things that are common to all these tests. So I offload that work to helper methods, and then I just call the helper method. So add all ratings is a method I wrote that's going to take a linked list, or rather the head of a linked list, so a reference to this node, which has a reference to this node, which has a reference to this node. I'm going to take that linked list and give it the song as well. So this method takes the song that I created with no ratings yet and all these ratings that I expect, and then it's going to go through the song, go through the linked list, and as long as the node that I'm currently looking at is not null, I'm going to add that rating. I'm going to call your add rating method of your song class with that rating. Get value is going to give me a reference to a rating, since that's what we have a linked list node of. So we're going to get that rating and add it to your song, and then recursively call add all ratings on the next value. So as soon as, if we're at the last node, for example, if ratings is a reference to the last node, we're going to check if it's null. It's not. So we're going to add its rating to the song and then recursively call this method with the same song and ratings.getNext, which if we're at the last node, this will be null. So we're going to call the method with ratings equal to null. We're going to see that ratings equals null. We're going to hit our base case, which does nothing and just returns back up the recursion. So this will get our ratings added in the order that we expect. Carl is added first. Paul is added next, which is appended, not prepended. So making sure that you get your order right in your code as well. This is appended, and then Jesse is appended in that order. So the final list should be in the same order as this expected list. And I'm going to use this expected list as the list that I'm going to compare to make sure that you're returning the right values in the right order from your get ratings method, which I do next. I call your get ratings method. This should give me a whole linked list node of linked list of ratings, give me one reference, just the reference to the head of that list, which will have a reference to the next node, which will have a reference to the next node, etc. And then call my second helper method check ratings list, which is going to go through both linked lists simultaneously and compare all of their values in step. So I'm going to check the values of the first node of each linked list, and then if they're the same, I'm going to move on to the next node in both lists, and then the next node, and just compare every single node to make sure that they have the same values all throughout the list. And for this, I have a little bit of chain of helper methods here. So first, if expected is null, I've reached the end of the list. I'm going to assert that we've also reached the end of the computed list. And as long as we have, then that's the base case. We're done, and these two lists are the same. So for example, if you call this method with null and null, it's going to hit this check and say, yep, these are the same. They're both null. Everything's fine. If they're not, if expected is not null, we're going to assert that computed is not null. So one big thing when you're comparing data structures like this is you have to be aware that they can be different sizes. And we can't just call computed.size expected.size. Actually, I guess we could. Like we'd have the size method, right? Yeah, I gave you the size method here. So we could, but I want to show how to do it this way. If we don't have a size method. So if computed is not null, if computed is null and expected is not null, then we've reached the end of the computed list, but not the end of the expected list. So we expect more things, and there are not more things. So we want to fail this test. Computed needs to not be null at this point. This is an important check. If you don't have this check and you get to the next line with computed equal to null, computed.getValue is going to give you a null pointer exception, and your code's gonna crash. In Autolab, you're gonna get your code testing this incorrect solution had an error. The error is null pointer exception. That's the message you're gonna get. And if you take that to office hours, I'm going to say add your null checks. You have to check for null. Make sure things are null when you expect them to be null and not null when you expect them to not be null. And there is, by the way, assert not null. So just like we did before, we're going to import all of our asserts. And we have assert not null. Why does that give me an issue? I assume that's just because I have errors all over the place. That should be fine. I think it's just because I have errors here. I'm not going to worry about that one. That should be fine. And then, likewise, assert null. So if expected is not null and computed is not null, I know each of these are references to linked list nodes, and now I can start asking them for their value. So I'm going to compare these ratings, get the value of both of them, and call another helper method, which is going to compare two ratings, which is going to compare the ratings and the reviewer ID, like we saw in the other tests. But I wrote a helper method here because I don't want to, I just wanted to offload that to a different method. And then recursively call computed check ratings list on the next value in both lists. So we're moving on to the next node in both lists simultaneously, and then recalling the method, going through the process again. And that's the bulk of what I really want to talk about here. I can skip through a bit of the rest of this unless there are questions, of course. So I'm adding in the ratings in a specific order, and then check ratings list of my expected, and I have these backwards here too. Expected and computed. Computed is whatever I got from calling the method that I'm testing, and expected is whatever I expect that method to return. And then I'm going through both lists and making sure they have all of the same values throughout these lists. And if they don't at any point, now notice my helper method does have the asserts in it. So if at any point these lists do not have identical values, one of these asserts is going to be false and the test is going to fail. By when will the quiz results be out? I can't give a solid answer for that. My policy is always I'll get results back within 1 week of the time that you took it. But given that this is such a short semester, I think we got to get them back quicker than that. I'm tempted to say by the following lecture I should have them out. But I don't know if I can guarantee we'll get a 48-hour turnaround. But that'll be my goal. And it depends how Gerlene's schedule lines up. Hopefully she can put a lot of hours into grading sooner rather than later. But I'll give a vague answer to that. At the absolute latest next Tuesday, but I think that's way too late. So that's that one. And then the rest is testing each one of the methods. But the strategy of this is getting what I expect to be returned, getting what's actually returned by calling the method that we're testing. So get ratings is the method that we're testing, and then making sure that those two values are the same. It gets tricky when it's two linked lists that we're comparing or two array lists that we're comparing. We would have to do a similar thing. I would iterate over the indices of the linked lists, get the value at that indice for both lists, and then make sure that they are the same value. Which is something you'll have to do in task 4, I believe is the first time I ask you to do that. So this same idea, but without recursion, you can use a loop when it comes to array lists pretty effectively. But I believe task 4 is when you'll be doing that. With the when we get to the movie class. I'm pretty sure it has to be task 4. that asks you to create the movie class and test it. And then kind of the same thing. The testing doesn't get more complex as we go through this assignment, for the most part anyway. It's the coding that gets a little trickier. So I think I can go through this pretty quick. I'm creating a linked list of size 3, calling add all ratings. So I have this song with these 3 ratings in the order Carl, Paul, Jesse. And then asking, did reviewer rate song? And making sure that your reviewer rate song returns the right answer. And I'm fairly comprehensive on this one, at least for this data. I'm asking for each of the 3 values, and then 2 values that don't exist. These 3 test cases are all pretty different. When it comes to testing, you're looking for a nice variety in your tests, and all 3 of these test cases are testing something different, even though they look fairly unassuming. But the first one, I'm testing, is your code checking the last node in the linked list? Which is a very common mistake when you're first working with linked lists, is to write a recursive method that doesn't check the last node of the linked list. For example, if in my check ratings list, if right here I did .get next, if next is null, then check if this .get next is null. Like, this test is gonna work in a lot of cases until the relevant value is the last value in that linked list, because that's never being checked. Where if next is null, we're stopping without ever checking the value of the last node. Very common mistake. A lot of you will probably make that mistake, and it's not that big of a deal. It's a learning experience. But checking the last node, checking a node that's internal to the list, and checking the first node. What happens if what you're looking for is the very first node is similarly to the last node? It's easy to make that mistake and forget to check the very first node of the list. And then, of course, if it's not in there, those last two tests are pretty much the same. Unless you have something weird in your code where you're not handling empty string. I just like having that edge case in there. This looks very similar to the first test. I have three ratings in my linked list. I'm adding all those ratings, except I'm adding all ratings 3 times to make sure that your code handles the duplicates just fine. So at this point, when we call add rating, if that user has already rated the song, you should not add that rating. So after adding all 3 ratings, adding the 3 ratings again, adding the 3 ratings again, these 2 method calls should not have any effect on your song. It shouldn't affect memory at all. These should do absolutely nothing, because your code will say, no, this reviewer already rated this song. They are not allowed to review it again or rate it again. So I'm not accepting these extra ratings. And making sure your get ratings is still just the 3 ratings from the expected list. I said I wasn't going to go through these, and then I did anyway. But average rating, I'm adding some ratings and then making sure your average is correct. If the song has not been rated, the homework says that average rating should return Did I not add that in the homework description? Oh, I messed up. Yeah, it should say that explicitly. That if there are no ratings, the average rating should be 0.0, because it is undefined, so it should be 0.0. I guess I define it in the test itself, so at least it's not a surprise when you submit to AutoLab and it's like, oh, yeah, we were testing that. But yeah, that should be added to the description. I'll have to remember to add that. Average rating should return 0 if it has not been rated. And yeah, I still forgot. Even I had another semester to add it in. I still forgot. And then I read this after, I remembered and read this after releasing it. And then just in case somebody started right away, I'm like, well, it's too late to change it now. But I didn't add any ratings that are invalid and then force you to ignore the negative ones. So we all get a pass on that one. And then remove rating by reviewer. I think this is the hardest one code-wise. Testing wise, it's not overly complicated. I'm going to add these 3, or actually, no, I'm not. I'm expecting these three, Carl, Paul, then Jesse, kind of like we did before. But I'm going to add them manually, which, by the way, if you don't want that first helper method, if you're writing your test that tests the linked list, you can just add your ratings manually like this. There's nothing wrong with that. I'm going to add 4 ratings, remove 3 ratings, add 2 ratings back in, making sure that Paul and Jesse used to have 5s, making sure that they have 2 and 1 here. So I expect a 2 and a 1, and maintaining the order the whole time. New ratings should be appended to the end. And making sure that the final ratings are these 3, Carl, Paul, Jesse, with 3, 2, 1, because that's what's left. Carl with 3 is the only one that's left after removing the other 3, and then Paul of 2 is appended to the end, and then Jesse of 1 is appended to the end of that. So after all these adding and removing and adding again, this is the last one that we should have. And this isn't that robust of a test. Like, I have a test that's doing quite a bit of stuff, and I only have 1 assert. I'm just checking the list at the very end here. So this could be more robust. Actually, all of these could be a bit more robust. Could have more testing in all of these. Maybe I'll have to add that for future semesters. But there could be more testing in all of this. All right. Where am I going? All right. Again, any questions on that, let me know as we go. I'll be happy to go back and do some more explanation on that. But I wanted to make sure I get that out there because, 1, it's relevant to Task 2 and Task 3. So working on those, of course, just understanding what's being tested. But 2, and the more important point is when I give the test for Task 2 and Task 3, the whole point of that is that you're studying those tests and using those as examples of how you can set up your own testing. So you use those as examples to learn testing without being forced to write your own tests, because in Task 4 and 5, you'll have to write your own tests that are similar to the ones that are given in Task 2 and 3. So if you're studying those tests, when you get to Task 4 and 5, you'll be ready to write your own tests that are in a very similar style to the ones we just saw. So if you're not studying those tests, Task 4 and 5 will be very, very difficult. If that's the first time you're even thinking about how to test classes, that's very difficult, which is what a lot of students tend to do. And then I got flooded with questions last semester of how the hell do I test this stuff when I threw Task 4 at the class. They were like, I have no idea how to test this stuff or what I'm doing at all, because they never studied the Task 2 tests that I expected them to study. So I want to make sure I got that in lecture this time. Make sure it's out there so everybody sees this is how the testing works. Because I do use a few strategies in there that I don't show otherwise in lecture. All right, but let's move on. We don't have a ton of time, so I want to make sure I get this one in as well, because there are a few more testing tips and things that we haven't got in here quite yet. So here I have, and this is in the week 11 examples. I think I have to officially just move this up earlier in the course. I don't know why I waited till week 11. We had a tips and trick like testing week, kind of like what we're doing right now. But it came so late in the semester. Some of this has got to be moved up. But I have the computing grades. This is a combination of 2 methods that we've already seen. The letter method, that's going to take the score and give you your letter grade, and the plus minus method, which is going to take your score and figure out if it's a plus, a minus, or no modifier at all. And what we want to do is test this method with the goal of running the debugger. The debugger's not going to get as much attention as we always hope, but let's get to the debugger at some point here. Delete some imports here. Assert equals. Let me do my star here and get all my asserts. Let's write some tests for this first. So what's this method supposed to do? We have a compute grade. That's what we're actually going to test. And it's going to call both of these methods, which could actually be private. These are both helper methods. And compute grade is going to call letter and concatenate that with your plus minus to get your final letter grade. And here's the grading scheme of the course. Now let's write some tests for this. When I'm writing tests like this, I like to get the description or any useful information just right there in my test class. Or I would do, if this were a homework write-up, I'd do what I did in the previous examples, have them side by side, the write-up and my code, my tests, right next to each other, so I can always look at, what am I actually doing here? What am I trying to accomplish? I always, try not to lose focus on that. So what we want to do is, in computing grades class, now this is a static method. So since this is a static method, I'm going to call it through the class itself. And since this class is in the same package as my tests, which isn't always the case, in your homework it's never the case, but since it's in the same package, I don't have to import computing grades either. If they're in different packages, like in your homework, you always have to import your class, but you all know that because you got through the through task 1, where you have to import your problem set. Actually, I think I have the import in the handout code, so maybe you didn't have to think about it, but you do have to have the import statement there. Here I don't, because they're in the same package. So computing grades dot compute grade, and let's say 80 in our chart would be a B minus. I'm gonna calculate this as my computed. So when I actually called the method, or sometimes, let me call this actual. Sometimes I'll call this actual. This is what I actually got. When I called the method that I'm testing, which is the compute grade method, this is what I actually got. And what I expected is going to be the string B minus. That should be a B minus. And then I'm going to assert. And I'm going to start using assert equals. Now that I mention it, I'm going to start using this throughout the course. My expected first, which I always forget, and then actual. And that's going to be one test case that I have. But we already know how to do that, and this is tips and tricks. So what I want to show is a way to organize your test cases in a way that's just going to keep things more organized, I guess. So what I'm going to do actually is create a hash map, and this is a common strategy I like to use. When I have input-output behavior, I have a method that takes one input and gives me an output. I'm going to create a hash map of inputs to expected outputs. It was asking for the import. I used the keyboard shortcut and got the import up here. That's going to equal a new hash map. I didn't give it a name. I'm going to call this test cases. And then I can do test cases dot put. And then let's get my test case down here in this hash map. So, the problem that I'm solving here, by the way, is that if I do it this way, I have to do this. I'm going to duplicate this. I'm going to call this like actual 2, expected 2. And then I'm going to inevitably forget to update one of these. And then I'm going to have a jacked up test case. If I do remember, I have to go through and like do something like this. And then do that for every test case that I want. I don't want to have to do that. That's tedious. It kind of sucks to do it that way. So what I'm going to do is put all of my test cases in a data structure. So like 80 should be a B minus. And it should be that simple to add a new test case. I'm just going to put new values in my hash map. 85 should be a B. And then when I want to actually use my test cases, we know how to iterate over the keys and values of a hash map after test 1. So I'm going to iterate over the keys, int, and I'm going to iterate over them as ints, not as integers. Java's going to auto-convert to the primitive type for me. Int input in test cases dot keyset. Oops. And I'm going to reuse this code that I have. But the actual, instead of hard coding 80, actual is going to be input, whatever the key is from my key set. And my expected is going to be my test cases dot get the value at this key. That's going to be my expected output, and then the assert equals is the same. So this loop is iterating over all of my test cases and running all of my test cases one at a time without having to like rename variables or anything. And now if I want to add a new test case, I want my 100 to be an A+. If I want to add a new test case, it's simple as that. So now when you're going to Autolab and Autolab's like, you need more testing, and you come to office hours and I'm like, you need more testing, and Gerlene's like, you need more testing. You don't want to be messing around with a whole jacked up mess of tests. You want to be able to do something like this. I need more test cases? Fine. Let me just add 5 more test cases just like this. Let's get something in the C range. Oops. 74 should be a C. Let's do 61 in the D- range. Let's get at least one F in here. 55. Let's check the boundary. I like to check boundaries, like in the very first lecture. And let's check our edge cases. A 101 is an invalid grade. Whenever we have a string like this, any method names also that have to be exact class names, what I like to do is copy, paste. The frustration of having some typo in here, or even worse, like a lowercase g. The frustration of having a typo and spending hours submitting to Autolab and then going to office hours and figuring out that that was your issue, just cut and paste. You can't make a typo when you cut and paste. I mean, you technically could, but you could have like an extra trailing space here. That would also mess things up. But it's much harder to have a mistake. So we have some test cases, and I'm going to take advantage of the hint text here. This is something I didn't talk about much yet, but I want to talk about it here because it's going to come in very useful. Is if this assert fails, I want to see why it failed. Now, we'll get a little bit of information. Actually, we'll get plenty of information in this case. Because I'm using assert equals actually will give you more information than assert true. Assert true will be like, well, I expected it to be true, but it was false. Assert equals will actually give you some information about the comparison that was made. It'll say, I expected this, but actually got this, which gives us a little information, but not a ton, because we still have to figure out what test case it was. So I'm going to add my hint text here, which if this fails, I'm going to put mostly the same thing that the library will tell me. Expected this, got this, but importantly, on what input we gave it, because the library is not going to tell us, JUnit's not going to tell us what the input was, because it doesn't really know. It can't deduce that from our assert. And we have a decent test case. I would hit I like to hit every single letter grade here and have a wide variety of test cases, but this is a good start. Actually, let's get one more invalid grade, because a -1 would be an invalid grade. Let's get at least one negative number, just so we can say we got a couple edge cases in there. And let's run this test. Who thinks this test is going to pass? I don't. Spoilers. All right, so we run our tests, and the test fails. On input, so this is what the library will tell you, expected and actual, which is good, and since all of our test cases have unique outputs, we can actually deduce that this was on input 80, which is an unfortunate coincidence because I wanted to talk about hash maps being out of order. Your test cases won't be in the order in which you added the key value pairs to your hash map. Let me get that example out here. Let's get rid of the first one because that was just a horrible coincidence. Let's run this again. So on input 100, so it did skip 85. So the order is going to be random-ish. It is deterministic, so it will be the same every time. But it's random to us. It's based on the hash value of the keys, which is why it's a hash map. that is going to be the order in which they're iterated over, which is pretty meaningless to us. Let me get 80 back because 100 is an edge case. All right, so we expected, this is what the library will give us, what expected and actual, but our hint text is going to give us a little more. Expected B minus got F minus on input 80. So instead of 80 giving us B minus, we got F minus. Oh crap, what do we do? So here is finally, with only 10 minutes left, yikes, I want to get into what's called the debugger, which is your best friend, your most useful tool while debugging. You write your tests. I recommend writing your tests first, but I'm not going to harp on that. I have in other semesters and nobody does it anyway. So I recommend writing your tests first, then writing your code, and then running your test as you're writing your code to see your progress on your test cases. And if you have really good test cases, it's going to help you write your code because you can see exactly where the errors are. The tests are pointing out, identifying this error that we have, this bug that we have in our code. And then once you identify a bug, run the debugger to see why that's the issue. And once you see why that's the issue, then of course fix the bug. The debugger, I'll give, I don't know how much I'm going to fit this semester, but at least 10 minutes. This will be your first 10 minutes of debugger. And I'm always happy to show this in office hours. But write your tests, write your code, run the debugger until all the tests pass, then submit to Autolab, and then Autolab can be like, no, that's not good enough. And then you got more work to do. If you write great tests, this isn't the best. I would write a lot more test cases here. But if you write great tests and learn how to use the debugger, you'll never need Piazza. You'll never need office hours. You know, aside from maybe there's some obscure thing where I have something weird going on in Autolab. You won't need anything. You'll be able to solve these problems on your own. I'll hold to that forever. It's such a powerful tool. The debugger. So we're going to go over to our line numbers here and click right next to the line numbers. That's going to set what's called a breakpoint. What this does is when we run the debugger, it's going to run our code and then stop right at the breakpoint, right before this line is executed, and show us everything that's happening in memory. So to run in the debugger, instead of, you know, everywhere where we would run something, we always go to run, right next to it has always been this debug button. Over here, there's the debug button. Up here, there's the debug button. I'm going to run this in the debugger. It runs my code, stops at the breakpoint, and shows me everything in memory. Here are all the stack frames that are on the stack. JUnit has all kinds of overhead, tons of stack frames before it actually calls our code. Then the one stack frame we care about, the one that we're in for this test method, test grade. And everything that's on the stack in this stack frame. So test grade has this, which is a reference to the test grade class, reference to an object of type test grade, which isn't relevant for what we're doing here. And then test cases, which is a reference to a hash map at 1178. So we have a reference to an object on the heap. And if we click the arrow, we can see all of the instance variables, all the values that are stored in that object on the heap. So clicking the arrow is like following the reference over to the heap to see what values it has. And we can see all of our key value pairs in there in randomish order. And then input is what we're getting when we're iterating over the key set. We got input equals 80, also on the stack inside this stack frame. And then we're going to enter into compute grade. For that, I'm going to click this blue arrow. For now, for first running the debugger, if you know how to start it and hit this blue arrow, those two things alone will give you unfathomable power compared to not running the debugger at all. Step in 2 is going to advance your code by one line. So I'm going to click this button, and the next line is inside the compute grade method. So I can see that I have another stack frame. I have the compute grade stack frame. Test grade is still on the stack, and here are all the variables inside that stack frame. And then in compute grade, I have the score, the parameter equal to 80 inside this stack frame. So it's the same information that's in your memory diagrams, albeit in a different format. It's displayed a little bit differently. You can't really do separate windows like this in your memory diagram, so we do separate solid boxes. So this stack frame is currently active. It's going to, if we advance one more line, it's going to create another stack frame. It's going to forward score to the next stack frame. So we still have the compute grade stack frame with score equals 80, but we also have the letter stack frame with score equals 80. We're going to get letter grade equals invalid grade added to the stack. And technically, we can see that technically strings are objects on the heap. There's some extra stuff here. We can click the arrow and see the object. We're going to pretend they're on the stack, so we're just going to pretend this arrow isn't here, and it's just the value invalid grade on the stack. Tens is going to be 8, integer division with 10. If score is less than or equal to 100 or greater than or equal to 0, and it's even telling me that those are both going to be true, then we're going to enter this conditional. Otherwise, we would skip it all and just return invalid grade. And then if 10's greater than or equal to 9, which is false. If 10's greater than or equal to 8, which is true, we're going to set letter grade equal to B. So letter grade is about to get the value B, which is what we expect. We're expecting... Oh, I didn't do my expected first. Probably should have just for the debugger example. But we're expecting B minus. So we hit the letter grade equal to B. Cool. And then we can start seeing where the bug is. We're going to check the next conditional. If 10's greater than or equal to 7, that's true. So we're going to set letter grade equal to C. If 10's greater than or equal to 6, well, that's true. So we're going to set letter grade equal to D. If 10's greater than or equal to 0, we're going to set letter grade equal to F and return a letter grade of F. It's a pretty big problem. Then we're going to get into plus minus. I don't want to go through the whole thing. We already saw the bug. We saw a bug. And the bug is that we were checking conditionals that we don't want to check. We want else ifs, not consecutive. Oh man, I can't type else. Not consecutive ifs here. So if any one of these is true, we don't want to check the rest of these conditionals. So let's get our else's in here. The last one could just be a flat out else if we wanted it to. And we're feeling good. We found a bug. We fixed the bug. Let's go back to our tests. I'll remove our breakpoint and run these again. Let's see if our tests pass now that we fixed our bug. No, we still have an error, and we have a big one here. Actually, it's not even the error I expected, but I expected it to be A minus here. So with a grade of 100, if we look at our grading scheme, if you got 100, you earned an A plus in this course with this grading scheme. Of course, not 116 because we don't use averages and stuff like this. But if you got 100, you earned an A plus, and this code is giving you an A. This is a huge bug. If I have this bug when I'm computing grades, and somebody earned an A, but I gave them an A minus or anything that's not an A, when they got a perfect score in the course, that's an issue. A student's rightfully going to be very upset about that, and I got to go change some grade in the hub. So let's do this again. Let's see what happened here. I'm going to go here. I'm going to set my breakpoint again, run the debugger again, and then we're going to learn one extra button. We'll get one more button in the debugger now. I'm going to look at the input. Input is 80, and what I'm going to use is the resume button. This is going to resume the execution of my program until it hits another breakpoint. So I'm going to resume the program. It's going to compute grade. It's going to get the expected. It's going to run assert equals. It's going to get the next input from the key set. And then it's going to get to this line again, hit that breakpoint again, and then stop again. So I'll resume. It goes through that whole test case. And we know that that passed because the program's still running and got to the breakpoint again. Assert equals. If this is if this assert fails, the program stops and the test just fails. So we know we passed that test case. -1, resume. So we passed that test case, and now we're at the input 100 that we're concerned about. So now we're going to step into again to see our 100. And we did get the right letter score. Actually, I am going to do one extra button here. we're back in letter, but we got the right letter for this. We did get an A, so we're okay with that, but we didn't get the plus on there. So I want to skip this stack frame. For that, I can go step out, and what that's going to do is whatever the currently executing stack frame is, it's going to run until that stack frame returns or ends. So I'm just going to completely skip that stack frame and get out of the current stack frame, go back to compute grade, which is about to run the plus minus method, get this stack frame, and let's see why we're not getting the right modifier here. So we have if score less than 100 and greater than equal to 0, which is false because we are 100. Oh, that's why we didn't get what we wanted. So we're just going to return no modifier. So we want this condition to run even when it is 100. Oh, actually I don't. Even when it is 100, let's do this just for the sake of argument. And then run this code. Oh, that's the end of lecture actually. So what we want to do, so that's still going to be a bug because the ones is going to be 0, which is going to give a minus, which is what I expected to begin with. So we actually want to separately handle this edge case. If score equals 100, return plus. And we'll handle this as a separate edge case, and then we can leave this as a less than. Let's run our test just to make sure we're done with all the bugs. And then that's the end of lecture. Oh, no. Oh, yeah, the F minuses. Greater than equals 60. So, of course, I purposely put a bunch of bugs in here so we can run the debugger. It's a debugger example. But if we fix that too, we don't want F minus and F plus. Those don't make sense. We would run the debugger, see why that's happening, and then change this to 60. And then we have our tests passing. All right, so I'll take a quick break and then hop into the office hours Zoom meeting. Have a good day, everyone. See ya. Hopefully you all did great on the quizzes. We'll try to get some grades out. I'll talk to Gerline and see